Algebra 2 classwork solutions on exponential functions, exponential growth and decay from April 29th. Number 2, the equation given y equals 55 times 1 minus 0.02 close parentheses raised to the t power. In this case, y is the new amount. 55 would be the original amount you start with, or the initial value. And then you would have 1 minus a decimal here. So since we're subtracting, it's exponential decay. So that's part A. And it's raised to the t power, where t is the time in years. Sometimes they would use x for the time, or t in this case. So part A asked if it was exponential growth or decay. It's exponential decay since we're taking off a decimal. Part B, what was the initial value? The initial value is always in front of the parentheses, so that would be the 55 here. Part C, what is the rate of growth or decay? In this case, it would be the rate of decay. This is always expressed as a decimal, so the R value is a decimal, 0.02. However, that would be 2%. The way that we make a decimal to a percent is we move the decimal point 2 times to the right. So this is 2% rate of decay. Question number 3. The equation is y equals 100, parentheses 1.25, raised to the t power. In this case, they have already combined the 1 and the 0.25. So another way of looking at this is that this is y equals 100 times 1 plus 0.25. This way you could see the rate a little bit more easy. And part A would be that we're adding on a rate, so this would be exponential growth. Part B, the initial value would be 100, since it's the value we start with before the parentheses. And part C, the rate of growth in this case. And again, 1.25 is not the entire rate. The rate would be the number added to 1, so it would be 0.25. And if it's asked as a percentage, it would be 25%, since we would move the decimal point twice to the right, and it would be 25% growth each time it's applied. Our next question is number 10. The population of a small town was 3,600 in 2005. So the population was 3,600 people. This population increases by 4% annually. Meaning that every year, the population is going to increase by 4%. Whenever we're dealing with an increase of a percentage, it's an exponential function. And the question says, part A, right, an exponential growth function. Since we're increasing the population, we're experiencing exponential growth to represent the situation. Started with y equals, that would be the new value. Y equals, you're going to take the original amount of people, which is 3,600. That's how many you start with in that year. Open parentheses, take 1 and add, since it's growth, add on the rate. And the rate is 4%, however, take the 4, the decimal point is behind the 4, but we want to make it a decimal, so we're going to move the decimal point twice to the left this time. So the R value is going to be 0.04. So we're going to be taking the 1 and adding on 0.04 to that, or 0.04. And we raise it to the t power, or you could put x. And that would represent the number of years. Part B, what would the population be in 2025, and if needed, round to the nearest person. So we're going from the starting year of 2005 to 2025, meaning that we have added on 20 years. So in place of t, we're going to put 20. That's how many, t is the number of years that have passed. So we're going to evaluate this at t equals 20. Y equals, take the 3,600, open parentheses, 1 plus 0.04, raise it to the 20th power. You're not going to raise it to the year number, you're going to raise it to the amount of years that have passed. We could write this a little bit more in a condensed way with y equals 3,600 times 1.04. Combine these values together, raise that to the 20th power. And we're going to do this with our graphing calculator. 3,600 parentheses 1.04, which accounts for the 1 is the original value and the 0.04 is the amount added on as a decimal, 4%, which is 0.04 as a decimal. Raise that to the 20th power. And you're going to get 7,888.04. And we know that we can't have a fraction of a person, so we're going to round this value up. $7,889 people.